So for compound interest, for the compound interest section of the syllabus, you need to know both how money can grow in a compound interest way, or how money can depreciate, how it can lose its value. So for both of these things, we're actually going to use this formula that is provided for you on the formula sheet. FV equals PV times 1 plus R over 100K raised to the NK power. Now, okay, let's see. My little box was a little weird. Alright, so that NK is still here, so cool. Alright, so now when we are plugging into this formula, we need to know exactly what each thing stands for. And fortunately, the formula sheet does remind you. So the first thing, FV, stands for future value. So future value is what you're going to have in your pocket or in your account at the end of the question. So future value. PV is present value. That's what you have at the very start. So PV is present value. R is the percent per year. Percent interest per year. Not to be confused with common ratio in geometric sequences, which we just did. So in this case, R is the percent interest per year. K is the number of compounding time periods per year, and I will explain what that means. Number of compounding periods per year. So for example, if it's compounding monthly, that means it's compounding 12 times per year, and therefore K would be 12. If it's compounding semi-annually, it's compounding twice per year, so K would be 2. Alright, so number of compounding periods per year. And N is just the number of years. Number of years is N. Okay, so the best way to grasp this is to actually just look at a question. So let's make up a question here. And in the question, let's say we start off with $1,000. And it's compounding monthly for 8 years. And I would like to know how much will you end up with at the end of that time. So it's compounded monthly for 8 years. I would like to know what you have in 8 years. So what's the future value? So FV, and I'm going to just rewrite the formula here, equals PV times 1 plus R over 100K raised to the NK. We don't know what the future value is. That's what we're trying to find out. The present value, which you have in your pocket at the start, is $1,000. So that goes there. Times 1 plus R, the percent per year. I didn't tell you what that would be, so sorry. Let's get that back up into the question. It's 24% per year, or per annum. And again, that would be given to you. I just forgot to give it to you earlier. Alright, so 24% per annum. That would be a given number. So now that we have that, now we can put it in for R. Or R is 24 over 100. Okay, so it's compounding monthly. And K is the number of compounded periods per year. Since there are 12 months in a year, K is 12. It's compounding 12 times per year, monthly. Raised to the NK power. So N, 8 years, so N is 8, and K still is 12. And then to figure out how much you have at the end, you type all of that in your calculator, and your answer should be, so yeah, it should be $6,692. $6,692.93. And remember that since we're dealing with money, we always round to 2 decimal places unless otherwise stated. Now, that question asks how much you end up with. Suppose instead the question didn't say how much money do you have at the end, but it said how much money did you make, or what was the interest earned. So if it asks for the interest earned, that means it's really asking how much extra money do you have. You know, you walked into the place with $1,000, you walked out with over $6,000. How much extra do you have? So in this case, if it's asking for interest, you will have to subtract. So let's get onto a new slide. Okay, so again, we started off with $1,000 and we ended up with over $6,000, $6,692. So the interest is the difference between those two amounts. The interest is equal to $6,692.93 minus $1,000, and that will give us $5,692.93. That is our interest earned. So again, our final value was $6,692.93, but our interest was the difference between that and the original amount. Now, we can go a step further with this, and we could actually back solve for any. Actually, let's do a new question. Let's move this out of the way. All right. So now, in my new question, I'm going to tell you how much I end up with. Let's have our future value at $8,000. And you started off, so the present value you started off with was, let's say, 5,500. And it was compounding yearly. At an interest rate of 5% per annum, 5% per year. And I want to know, how long did that take to happen? So how many years did it take for me to end up with over $8,000? Let's say over $8,000. How many years did that take to happen? So we can get this all in an equation, the same equation we were using before. So I'll get that down. FV equals PV times 1 plus R over 100K to the NK. Okay, so our future value, what we end up with, is $8,000. I said over 8,000 because it might not be exactly 8. It might end up being 7,000 and something, and then the following year it's going to go a little bit over 8. So we'll just say 8 and see what decimal we come up with. The present value is 5,500 because that's what you start off with. 1 plus R, and that's the percent interest per year, so that's 5 over 100K. Now, K, again, K means number of compounded periods per year. Since it's compounding yearly, the number of compounding periods per year is 1. So we don't have to write that there, but we'll write it there anyway. Okay. to the nk, number of years, we don't know what that is. So, and k is 1, so we don't have to put that there. So we don't know what that is, and we have to figure it out. Now, at this point, we have a few options. Logs is not on our curriculum. When you're trying to solve for an exponent, that would be an option, but it's not on our curriculum, so don't worry about what I just said. What other option do we have? Well, we have trial and error, and there's something on the calculator called Solver. And I will go through Solver at another point, but for now, let's use trial and error. But let's get this as simple as we can possibly get it before we try random numbers. Try and fail and try and fail and then try and succeed. Let's actually try first to simplify. So let's divide both sides by 5,500. Ignore my whistling telephone. Alright, so on the left side, 8,000 divided by 5,500 will give you 1.4545. Let's give another 145 equals 1. Let's make 1 plus 5 over 100 to the n. Now 1 plus 5 over 100 is 1.05. That raised to the power of n should give you 1.454545. Alright, so how do we do this trial and error stuff? Pick a number, any number. Let's go with 10. 1.05 raised to the 10th power. What would that give us? Alright, 1.05 raised to the 10th power gives us 1.629. Too big. But let's write this down. If n, put it in a little table over here. If n is 10, then our value over here would be 1.629. Too big. So let's split that in half. Let's try n as 5. So 1.05 raised to the 5th power is 1.28 or 276. Too small. So we have to go bigger. Let's try 7. 1.05 raised to the 7th power gives us 1.407. Getting warmer. It's a little too small, so let's try 8. 1.05 raised to the 8th power brings us over slightly. And that's what we're looking for. We're looking for the year when you go slightly over $8,000. So the number of years it takes for this amount to grow to over $8,000, the number of years that takes is 8. Oh boy, very, very loud. So to reiterate what just happened, we had all the values except for our number of years. So since we don't know how to solve algebraically for an exponent, we used trial and error. We tried 10 and it was too big because we were looking for 1.454545. We tried 10, it was too big. So we decided to go down and try 5, which was too small because again we're looking for 1.4545. We got 1.276. We went a little bigger, it was still too small. A little bigger, we got 8. And so we figured out that 8 years would be the first time, after 8 years, it would be the first time that our value is over $8,000. So I have just one more point to make, and that is to talk about the formula and how it affects depreciation. So what is depreciation anyway? Like when you buy a car and it's worth, let's say, $30,000. And then the next year, it's no longer worth $30,000. It's going to be worth maybe $27,000. And then after that, it's not going to be worth that. The value is just going to keep going down and down and down. That's called depreciation. So the only thing that you need to know about depreciation is that you need to understand that the formula changes slightly. It is still FV equals PV times 1 plus, actually, that's where the change comes about. It's no longer plus. 1 minus R over 100K to the NK. So for depreciation, since the value is going down, the sign in the formula changes to a negative. So if my car is worth $30,000 at the start, it's worth $30,000, and it depreciates at a rate of 4% per year. Depreciation this time. And this is happening for 4 years, no, 5 years. How much is the car worth at the end? How much is the car worth at the end? So we're still trying to find the future value. And our present value is still the starting amount, which in this case is 30,000. 1, but this time it's minus 4 over 100. And it didn't say it was compounding monthly or semi-annually or anything, so it's just 100 raised to the number of years, so raised to the 5th power. And when you type that all into your calculator, you should get 24,416.18. So in 5 years, that should be the value of your car after depreciation. Alright, so we started off with $1,000, and we ended up with, isn't this wonderful? We ended up with over $6,000. So $6,692.93. Holy cow, this did not